Hello, everyone. Today we're going to be going over the fives, which is the first acid base unit lab. Up at the top, it talks about a dry lab. It wants you to hop out on the internet and do some work with a simulation and try to learn some information. But we're going to go right into the wet lab rules. And whether you're here today or next week, these are some rules that we have to follow while we are in this unit. A, we can never place phenolphthalein into a bottle of acid or base. So this is phenolphthalein right here. If we were to dump that in any of these solutions, we would contaminate them. So we're never going to put them into bottles of acid or base. B, you can never let an eyedropper touch the table, another eyedropper, or another solution. And C, only take out one eyedropper at a time to avoid placing the eyedropper in the wrong container at the end and contaminating everything that would be in that bottle. So number one, it says look at the back of your front cover and obtain some information on phenolphthalein. Pause the video, go ahead and do that. So if we go to number two, it says phenolphthalein turns what color in the presence of an acid or a base? And if you read that cover, you find out that phenolphthalein turns pink in the presence of a base or hydroxide ions. Number three, it says you can use a spot plate. So this is what a spot plate is. It's got all these little holes that we can mix some chemicals together. If we ever do need to wash these, we'll wash them with tap water to get rid of most of the ions. We'll then spray it down with distilled water to get rid of any ions that are in the tap water. And then we'll dry it off with some paper towel at the end to remove anything that might still be there. Number four, it says don't waste solutions by using squirts. We want to be counting drops today. Number five, it says place 1 drop of phenolphthalein in a spot plate test to test if a solution is acidic or basic. So I'm going to put phenolphthalein in a cell. So I'm going to put phenolphthalein right here. Got 1 drop in there, and you can see it's clear and colorless. And it asks for number 6, is distilled water basic or alkaline? Basic and alkaline mean the same thing. So we're trying to find out if this is going to be a basic solution, distilled water. If it is basic, it'll turn pink. And I put some distilled water in there, and it remains clear and colorless. Therefore, we know that distilled water is not basic. Could it be acidic? It could be, based on the information that we have right now. But distilled water actually is neutral. It is neither acidic nor is it basic. So we just answered number 7. Number 8, it says you're given 2 bottles labeled X and Y. One is acid, one is a base. One has a molarity of 1 molar and one has a molarity of 0.5 molar. We need to figure out which is the acid, which is the base, and the molarity of each, and then fill out 10 and 11. So I'm going to take 1 drop of phenolphthalein, and I'm going to place it in this cell. I'm going to put 1 drop of phenolphthalein in this cell. So there's phenolphthalein in both of those. I'm going to grab X. I'm going to put 1 drop of X. And we can see that it turns a bright pink color. That means that X is a base. So we'll write down some information right now that X is a base. All right, let's try Y. We put Y into another cell with some phenolphthalein, and it remains clear and colorless. So that means Y is an acid. So now we need to find out the molarities. So if I take Y, which is an acid, and I put 1 drop with 1 drop of X, which is a base, and I shake it, it stays pink. I'm going to try 1 more drop of Y and put it in there, and I'm going to shake it. And we can see some of that pink is going away. I'm going to put 1 more drop of Y in there. And we can see some of that pink disappearing. If I shake it, I get all the pink to go away. So that means that the base is more concentrated. And it means the acid is less concentrated. So it's got less hydrogen ion in it, and the base has more hydroxide ion in it. So if we have to answer number 10, X is a base, and it is the 1 molar base Y is an acid, and the molarity is 0.5. You can see that it took 2 or 3 drops of 0.5 to neutralize the 1 molar acid. 2 drops should have gotten us right to the point, but there must have been a couple more hydroxide ions left over, and that's what allowed it to stay pink. Number 12, it says, now figure out what bottle Z is. So again, I'm going to take my phenolphthalein. I'm going to put a drop in the cell. I'm going to grab some Z. I'm going to put a drop of Z in there. And it remains colorless. So Z is an acid. We know that Y is 0.5 molar. We know that the base X is 1.0 molar hydroxide ion. That's the stuff that we know. So if I put 1 drop of this base in there, it should turn pink. And it turns pink for a second, and all the pink disappears. That was kind of neat. Now we put 2 drops of the base in there, and we can see the pink is still kind of moving around in there. There's a battle going on. The hydroxide ions are linking up with the hydrogen ions. Now I'm going to shake it a little bit. And the pink doesn't go away. So it took 2 drops of the 1 molar to turn the solution pink. So the acid must be twice as concentrated. So this is probably a 2 molar acid. We can test this another way. So if I put 1 drop of X in a cell and it's pink, 1 drop of Z should immediately turn it colorless. And if we look, it does turn it colorless. So that's a little bit of information, again, saying that the Z is more concentrated than the X. Let's try this again. Let's put 2 drops of X in a cell. Nothing happens until I add the phenolphthalein. Add the phenolphthalein, and it turns pink. So if I put 2 drops of X, theoretically, I should need like 4 drops of Z. 1, 2, 3. Let's give it a little shake, and it goes all the way around, all the way. So maybe Z is a little less concentrated than 2 molar. Maybe it's like 1.5 molar, something like that. That's pretty much the lab, folks, and this is the kind of information that you're going to need for the labs coming up. If I add a base and some phenolphthalein together, it turns pink. If I add an acid to that, so if I add an acid to this pink solution right here, what should happen? What color should it turn? So if I have a pink solution and I add acid, the pink disappears. If I have a colorless solution and I add some base to it, so I got a colorless solution and some phenolphthalein and I add a base to it, the pink reappears. So that's the kind of information that you're going to need in the labs that we're going to be doing in the next several days and the next several weeks. Have a good day.